Check. Hello. Check. Check audio. Hello. Check. Check audio.
Dr. Praveen, can you hear us? Please unmute.
Yes, sir, you're audible.
Okay, good.
Yeah.
And YouTube channel is also there, Priyanka?
Yes, sir. Yes, sir, it is live.
Okay. Fine. So, with your permission, we can start. Okay. Very good morning to each and everyone present here and online. Respected Chief Guest, Honorable Sri Kiran Kumar Sir, dear ISRS members, students all across the country, chairman and executive council members of all chapters, 28 chapters of ISRS all across the country, ladies and gentlemen, good morning and greetings from Indian Society of Remote Sensing and Northeastern Space Application Center. Today, we gathered to celebrate the National Remote Sensing Day, a day that honors the birth anniversary of the legendary Dr. Vikram Sarabhai, the father of India's space program. On this special occasion, we have with us a luminary whose career is deeply interwoven with the story of India's success in space technology and remote sensing, a leader, a scientist, and most importantly, an inspiration to generations of this country. It is my honor to introduce Padam Sri A.S. Karan Kumar, one of the India's most distinguished space scientists, former chairman of ISRO, and currently a respected member of prestigious Space Commission, which shapes the vision and strategy for India's space endeavors. Sir, from core of our heart, we welcome you. I take this privilege, and indeed it is my honor, to introduce Sri Kiran Kumar sir. Thou, few minutes are very less to introduce such a great personality. Nevertheless, I will take a brief time, sir. Sri Kiran Kumar sir, born on October 22, 1952 in Hassan, Karnataka. He holds MSc degree in physics and specialization in electronics from Bangalore University and MTech degree in physical engineering from Indian Institute of Science, Bangalore. He began his illustrious journey with ISRO in 1975 at the Space Application Center, Ahmedabad. He has steered the implementation of the application-oriented Indian space program, which has facilitated rapid development of the countries in many important spheres of Earth observation, communication, navigation, meteorology, and space science, as well as the development of indigenous launch vehicles and related technologies for providing assured access to space. He has led the design and development of more than 50 electro-optical imaging sensors flown on various space-bound platforms, which starts from Bhaskara in 1979. Further, his role is in the success of Chandrayaan mission and Mars missions, Chandrayaan 1, 2, 3, and Mars orbiter mission has been significant and made a great impact for the success of space program of our country. As chairman of ISRO and the Space Commission from 2015 to 2018, Sir led the organization to several remarkable milestones. The record-breaking launch of 104 satellites in a single PSLV mission, the operationalization of beginning of Navik navigation system, and strengthened international collaborations, including joint satellite developments with NASA and other spacefaring nations. He has been the chair of Committee on Earth Observation Satellite in 2012. He has made valuable contribution to Coordination Group of Meteorological Satellite, CGMS, Expert Team on Satellite Systems, World Meteorological Organization, ETSAT of WMO, and Indo-US Joint Working Group on Civil Space Cooperation. He was involved in various professional societies contributed a lot in various positions. He has been the president of Aeronautical Society of India and president of Indian Society of Remote Sensing. He is a fellow of Indian National Academy of Engineering, National Academy of Science India, Indian Society of Remote Sensing, Institution of Electronics and Telecommunication Engineers, Indian Society of System for Science and Engineering, Indian Meteorological Society, Indian Society of Geomatics, and many more. Sir is an elected member of International Academy of Astronautics. He has been conferred with honoris causa and DSc by 18 Indian academic institutions. In recognition of his contribution, he was conferred many awards, but most importantly, and it's a great matter of pride for all of us, that he received Padam Shri, one of the highest civilian award, by the President of India in 2014. Other notable honors conferred on him include Rajyotsav Award for 2015, Sir M. Viswesvaraya Senior Scientist State Award for 2013 by Government of Karnataka, Lifetime Achievement Award from Karnataka Science and Technology Academy in 2016, ISC Distinguished Alumnus Award for 2015, Gujarat Ratna Life for Innovation Award conferred by Gujarat Innovation Society in 2014, Lifetime Achievement Award by Andhra Pradesh Academy of Science in 2016, then Sir M. Viswesvaraya Centenary Award by University of Mysore in 2016, GM Modi Science Award in 2016, HK Feroda Vigyan Ratna Award in 2017, Santakova Award instituted by SRKKF Surat in 2018, ISRO Lifetime Achievement Award 2018, and many more. He has been conferred with prestigious 2018 International Von Karman Wings Award instituted by Aerospace Historical Society together with Graduate Aerospace Laboratory at California Institute of Technology in 2018. And very importantly, Sir has received Chevalier de l'Ordre National de la Légion d'Honneur, the highest civilian honor by the government of France in 2019. Above all, Sri Kiran Kumar Sir career embodied the spirit of ISRO, innovation, precision, and an unwavering commitment to use space technology for the benefit of humanity. Sir, it is indeed our honor to have you here, and I request all of you to welcome with the applaud to Honorable Kiran Kumar Sir. Now, after this very brief introduction, Sir, on behalf of Indian Society of Remote Sensing, all the members of Indian Society of Remote Sensing, as you are aware, currently the strength of Indian Society of Remote Sensing members is 6,542. And we are running a journal, publishing a journal with Springer, and every journal is having around 15 to 20 papers. So every year we are publishing around 200 to 250 papers, and this journal impact factor currently is 2.2. And every year we are also conducting one national conference with ISG, and 28 chapters every year they are conducting programs in their respected places for Remote Sensing Day, that is mandatory, and some chapters are also organizing the Science Day. So these are our activities. Sir, I again thank you very much, and I request you to kindly deliver your talk on the topic of India's space program, innovations and celebrations.
Thank you very much. Thank you, Agarwal, for giving that introduction and also providing me an opportunity to be here in ISAC and also interact with all the participants here and talk to you about India's space journey and how it has made a difference to the country. Thank you for providing me this opportunity. If you look at how India started its space activity, way back in 1957, humanity got a unique technological capability. Today, we are all very familiar how disruptive technologies changes the way we live in our societies. So in 57, Russia put an object into space, Sputnik, which went around Earth at that time, which was a result of an intense competition between America and Russia to demonstrate who is militarily stronger, who is more powerful. But you also realize 1957 was just 10 years into independence for India. In 1947, after many hundreds or even thousands of years of external rule, India had become independent. And 57 is just 10 years into independence. India is struggling to provide food, shelter, and education to its citizens. At that time, the powers that be were worried about how to make this happen. And if at that time somebody were to come and tell space technology is the way to go forward, you can imagine the kind of response that would have come. But then we had great visionary scientists like Dr. Sarabhai, Homi Bhabha, etc. Dr. Sarabhai, in fact, we are also celebrating his birthday today. So it was his thought process which said that the ability to go beyond Earth, put an object in space, can make a difference to the country. And in what ways it can make a difference was the question. So obviously he had seen, Arthur Clarke had already predicted that if you make use of geostationary platform, geostationary platform is nothing but if you can put an object at 36,000 kilometers altitude from Earth, and if you put it in equatorial plane, it takes exactly 24 hours to go around Earth. And this is the same time as Earth takes to rotate about its own axis once. So because of this relative velocity becoming zero, you can do line of sight communication from a tower which is 36,000 kilometers. That is, we are all very familiar. If you want to see farther and farther distances, we go to higher and higher places, tree top, mountain top, or tower. So this 36,000 kilometer altitude appears like a tower from which height one third of the globe becomes visible. So Clark had predicted that humans could make use of this for doing line of sight communication. So what Dr. Sarabhai was looking at, how can we take advantage of this capability of humans going beyond Earth and doing this exercise? So for that, initially, he had to convince his friends across France, Germany, Russia, and America. And then by bringing in certain specific activity, how the activity started in India is very simple. The sounding rockets were to be flown at a place in India which is known as, which has a geomagnetic equator very close to Tumba. So he convinced his friends that if we conduct upper atmospheric research at Tumba, the community, scientific community will get unique information set. And for that, not only he convinced his friends, but also convinced United Nations that a developing country like India should also be able to work in the area of this technology. So with sounding rockets brought in the form of kits, got assembled in Tumba. Probably many of you would have seen a church there, if that is where the first assembly happened. And even for doing this activity, he had to convince the fishermen in that beach to tell them that you vacate this place and allow us to conduct this experiment. One day the country will benefit. And even for that, he had to take the help of Father Pereira of that church. And with that process, they started launching sounding rockets from Tumba. And as though what he had promised to the fishermen was converted into reality, in 1999, what India started doing was by using orbiting satellites and looking at the color of the ocean in many different wavelengths, and through those observation identify where the chlorophyll is, and from the chlorophyll through the food chain of the fish identify exactly in ocean where if the fisherman goes he is assured of a fish catch. So you can see in 1999 when this event was made operational with a center in Hyderabad called Indian National Center for Ocean Information System, the information was being disseminated through pagers and electronic notice boards for the fishermen. And this act alone saved to the country between 15 to 20,000 crores a year, because lakhs of fishermen in our 11,500 kilometer long coastline depend for their livelihood on this fish catch. And with this process, one of the things that Dr. Sarabhai had promised became a reality. Another very important thing that happened was to convince the government also at that time, he had to actually conduct some experiments, and Professor Pisharotti had done an experiment using the false color infrared camera flown on an aircraft with root wilt diseases of coconut in Kerala. These images were taken from the aircraft and shown to the country that it is possible to pick up the information from remotely observing Earth. And this experiment demonstrated that remote sensing can make a difference, and remote sensing can be done through satellites in orbit. So Dr. Sarabhai had done one more thing. One of the key things that was required at that time was to reach out to the entire population of the country. So one of the things he said initially was, see, suppose we want to reach out information to the entire country. Country was at that time about 36 crore people. So now if I tell something to three people, and those three people in turn tell to another set of three people, so like that, if you go, you require probably about 27 cycles of events before everybody in the country gets to know what you want to tell. But then if you make use of a broadcasting satellite, then the entire country can be reached in one go. So he said that to reach out to the entire country, you can make use of broadcasting from satellite. And then he had worked with Americans to convince them. They were building at that time one of the most advanced technology satellite called ATSF. And that satellite had a large antenna, and using that, it was beaming signals on Earth. And this satellite was having a life of only 2 years. So in spite of that, Dr. Sarabhai was able to convince Americans that they should allow us to use that satellite for 1 year in India. And what was done is that satellite was moved over India, and in 2,400 villages of our country in 6 backward states, using a process which we are all very familiar today. Today, when we see television, all that is needed is a quarter-meter antenna on rooftop, a small set-top box on the table, and a TV. With that, we are able to see the broadcasting. You imagine in 1975, this concept was demonstrated by India using a satellite built by Americans, and almost half a rack height of electronic front-end hardware was designed and developed in India. And black and white television sets of ECIL was used. And in those villages where even power availability was in question, equivalent of today's, you can say, the systems used for battery backup systems and using such equipment, in 2,400 villages using a 10-foot antenna, the program was received, and instead of direct to home, direct to community television system was established. And for 1 year, India ISRO demonstrated to the country that space technology can be effectively used for reaching out to the people. If alternate method had to be used, you can imagine, you see in that when you are going on road, a microwave tower. Every 1 kilometer you have to set up a tower. So India is 3.25 million square kilometers. So you can imagine how many towers are needed if entire country has to be covered. But instead of that, one single satellite with some receiving systems on ground and distribution, you can make it happen on the ground. And also you can easily visualize if in 1975 you go and tell the people and who are running the government what you are speaking can be heard all over the country at the same time. Do you require more convincing for them to allow you to do this experiment? So anyway, that aside, that's how India convinced the powers that be that space technology is the way to go. Similarly, in this particular satellite, not only broadcasting but communication, and also there was a weather monitoring payload called VHRR, but of course that did not work in that particular mission. But then in 1975, when India demonstrated this, in fact, this year happens to be the 50th year. We are celebrating that experiment called SITE, Satellite Instructional Television Experiment. So we are completing 50 years of that. And when this event was conducted, it became the world's largest socio-technological experiment conducted, and it won Marconi Award at that time. Even though the technology of satellite was built by Americans, India demonstrated how developing countries can take advantage of this technology for enabling communication and broadcasting to be reached out to its citizens. So in this manner, in 1975, this experiment got conducted, and then the government approved our Insat program. And Insat program, we started building. At that time also, you can see how innovation happened right from beginning. And even during this period, India made use of all the opportunities that it was getting to build space technology capability. 1975 April also happened to be the first satellite by India put into orbit, Aryabhatta, which happened in April of 1975. This also, if you look at how it happened, the Russians had offered that we will help you build a satellite and launch. So India took up the task, and within a matter of 3-4 years, starting its work in some remote industrial sheds in Bangalore, it built a satellite, and the first launch happened in 1975. And then 1975 also the site experiment happened, and with these two together, the India was moving ahead in space program. Then the Russians also said, we will help you build 2 more satellites and launch them. India took up the remote sensing satellite Bhaskara 1 and 2, and the first Bhaskara satellite, in which I had the opportunity to start my career in 1975. The satellite was it was orbiting around 560 kilometer height, and it was a spinning satellite. It used to take pictures of Earth in 2 wavelengths, visible and near infrared, and the image size was 340 kilometers by 340 kilometers, and with 1 kilometer resolution. That's how we started our remote sensing from satellite observation. Today, you are familiar, starting with 1 kilometer resolution, we have reached 30 centimeters and built a huge number of capabilities, etc. So again, coming back to the initial period, Insat satellite was also conceived. Up to that point of time, 3 functions in one satellite was not being attempted by people, because we could not afford 3 independent satellites and 3 independent launches. We said we will have in the same satellite broadcasting, communication, and remote sensing. VHRR for collecting information about the weather over India, cloud movement, and through that cloud movement determine a whole lot of parameters. So 1981 onwards, the first round of Insat satellites were built as per our specification by an American company. But subsequently, we started building our own satellite, Insat 2 series, 3 series, and today also a whole lot of them we have been building. So in this manner, you can see how India started its activity. And then another very important thing that happened is with respect to weather monitoring and cyclone. So in the earlier period, when cyclones used to hit the coastal region, almost 10 to 15,000 people used to lose their life, because it was not known when the cyclone will hit the coastal region, and then people used to lose their lives because of that. But with satellite capability, you know that today you can predict in advance which portion of the coastal region within 20 kilometers positional error and half an hour in time error, you can tell days in advance when the cyclone will hit that region. As a result of that, disaster relief agencies are able to evacuate people and save their lives. Today, you have seen in the recent past, whenever super cyclones have hit also, the number is coming down to a single digit, where again, it is primarily because many of them do not heed to the advices given, etc. But then this is how gradually India started its space program of using building satellites which are put to different altitudes, 500 to 1000 kilometer low earth orbiting satellites, then geostationary orbit at 36,000 kilometer. And then as the satellite observations became more and more, remote sensing wise, we started our first operational remote sensing in 1988 by IRS, Indian Regional Remote Sensing Satellite series, building what was at that time a contemporary satellite of having multiple resolutions and multiple wavelengths, four band system. And then by 1995, India had built a satellite which was quite unique. Not it had what is called as a three-tier imaging system. That means in one platform you are getting 5-meter resolution panchromatic and about 23-meter multispectral, and also 188-meter wide field sensor. The idea was at coarse resolution you cover every 5 days the entire country, and in medium resolution about 24 days, and in high resolution maybe about 70 odd days. So with that you could cover, and this was designed specifically for the Indian region where the field sizes are small, etc. So by progressively building instruments which are making observation, then similarly in 2005 we built our first stereo imaging system, which again at that point of time was the best optical resolution, 2.5 meter dedicated same orbit stereo imaging system was built in that, and that provided information about three-dimensional data collection, digital elevation model, not only of our country but also of all the neighboring regions, etc. So progressively India started using the ability to go to space, and you will also notice that India is the only country which started space-based activity for non-military applications. Otherwise, every other country started space technology for military purposes only. But then, as we started growing and building our capability, one of the things you will also realize is if you have to remain contemporary and capable, you have to challenge the people who are working in that area, build more and more complex system. So in 2008, India also decided to build its first Chandrayaan mission, where for argument's sake, that man had landed on the moon way back in 1969, and then a large number of probes had touched the surface of the moon. But still, Chandrayaan 1, when it was launched in 2008, gets the credit for discovering the presence of water molecules on moon and also the processes of water molecule formation. This was demonstrated by 2000 in Chandrayaan 1, which again, in a way, rekindled the interest of the humans on moon. So you're seeing subsequently lot more missions are going to moon. Not only government entities, but also a lot of private entities are also getting into moon, etc. But then similarly, when we went to moon in 2008, from 36,000 to 380,000 kilometer farther. So you build a satellite capable of reaching there. And for that, we used our own launch vehicle. And here again, a lot of innovation is required. Innovation is required because the capacity you have in your launch vehicle is limited. And with that limited capability, you want to achieve something which is what others have done using much more capable launch vehicles. And it is here both the innovation that comes into picture with the capability of a launch vehicle, which was PSLV. You put a satellite into orbit around Earth in an elliptical orbit, and every time the satellite comes to perigee, you add some small velocity increment by firing the engine. So with each small addition, your apogee becomes farther and farther. So this process, using this process, we reach moon and then got captured on the moon, etc. Similarly, in 2013, when the Mars mission was done, you can see that we were trying to do that mission again with a launch vehicle, which is only our PSLV. And using that launch vehicle, you are putting a satellite just to appreciate the complexity of this mission. On the 5th of November 2013, when this satellite was launched, the task cut out for the satellite was travel a distance of 600 million kilometers. That's about 60 crore kilometers over a period of 10 months. And at the end of that, you imagine a cube of 50 kilometers on a specific day and time. That is 2014, September 24th, morning 7:30 a.m. To the second, this satellite has to be inside that cube. If it were not there inside that, it would not have been possible for us to reorient it and get captured in the Martian orbit. But then what all could have changed the trajectory of the satellite, if you imagine, even radiation pressure, sunlight falling on any surface produces a small force. It is like if you take a paper and blow your air from the mouth, it produces some micronewtons of force. It is that kind of a force, but that falling on the satellite can change the trajectory of the satellite thousands of kilometers away from our target. So not only should you be able to monitor the satellite, see its trajectory, control its direction, but also build intelligence into the satellite so that the signal you send from ground, when you are at 200 to 400 million kilometers away, it takes, even at the speed of light, many minutes to reach there. So it takes roughly, when it is farthest, about 12 minutes to reach, and you have sent a command from ground, it reaches there, it has performed action, it is telling I have done that, another 12 minutes, almost half an hour later, you know what is happening. Many of you, when you are operating your laptop, you switch on and it starts taking few hundreds of milliseconds extra. So you start feeling fidgety. My system is very slow. I want to get a faster system. So you imagine the people sitting on the console looking at what's happening. And then not only that, when it is about to enter the Martian gravitational influence, it goes behind the Mars, and that much period is another 60 to 70 minutes. So it's almost hours after the successful insertion has happened, you will come to know that it is happening. So anyway, basically the point is all these kinds of capabilities were gradually built, and India demonstrated that what nobody had done till that point of time in its maiden attempt, putting a satellite into the Martian orbit. So that became a great success, and then world started looking at India. And then we converted, again here also, if you look at remote sensing, using this mission, we were able to put it into an orbit which was highly elliptical. Farthest point was almost 80,000 kilometers. But then the advantage, we converted it into an advantage for us by looking at the entire globe of the Mars. So we, in fact, Chandrayaan, means mom, has produced maximum number of total global images of Mars compared to any other mission. So same way, subsequently, when we started getting into our Chandrayaan 2 mission, in Chandrayaan 1, we also had a moon impact probe. The moon impact probe was from the orbiter, something got separated, and then it had a free fall onto the surface of the moon. And the place where it hit the moon is called Jawahar Sthal. And then this was an uncontrolled descent. In Chandrayaan 2, our idea was make a orbit lander land on the surface of the moon, bring out a rover, move on the surface of the moon in a controlled manner. But then 2019, when this attempt was done, we fell short of successful descent within a few hundred meters. But then we also learned a lot of things about what were the inadequacies, and using that information in 2023, we were able to successfully land our Vikram lander, and Pragyan rover moved on the surface of the moon, and it generated a whole lot of information. And then for this, actually, our remote sensing instrument, which was sitting on Chandrayaan 2, which even today is producing the highest resolution images by an orbiter of moon. Even today, it is the highest resolution image from an orbiter. In fact, this images is what helped us overcome one of the problems between Chandrayaan 2 and Chandrayaan 3. If you have to appreciate, if you have to go and land in an unknown area, one of your requirements would be to find out, do reconnaissance of that region. That means collect data about that, make a good map, three-dimensional map, identify how many craters are there, how many boulders are there, whether you have enough gap between your legs and you can touch down without hitting the boulder. These are your targets. But before Chandrayaan 2, we had to depend on somebody else for getting some good quality images, because our own images from Chandrayaan 1 is only 5-meter resolution, whereas with this 23 centimeter resolution is what we are getting. So Chandrayaan 2 we used for creating entire 700-kilometer strip, and then the area where we were going to touch down. In Chandrayaan 2, we had identified a 500-meter by 500-meter area, whereas in Chandrayaan 3, we identified a 2-kilometer by 4-kilometer area. Within that, every 100 meter, you have a safe touchdown point. So we created such data sets and then used that. And in Chandrayaan 3, we had enough margin for the object to go from its orbiting position to that. So progressively, we built remote sensing information using this capability. So that's how when you saw on Chandrayaan 3, when we successfully landed on August 23rd, evening 6:04, it was a very successful mission because everything went with clockwork precision, etc. So here also you see what India has been doing right from the early times is generate information from your space capability of putting satellites into various orbit, near Earth orbit. And another very important thing was when Kargil happened, India found the inadequacy of navigation. And again, navigation system was built, which is very different from what others have done. If you look at GPS, GLONASS or Galileo, or even BEDO systems of these countries, it's a 24 to 32 satellite constellation, whereas India, both because of its resource constraint and other, decided to put navigation satellite constellation of only 7 satellites, and with that we were able to provide the essential information. In fact, the fisherman story which I am telling, one more thing has been added to that. Today, using our Navic satellites, a small battery operated gadget is fitted to the boat of the fisherman, and this gadget tells where he is in ocean, and then a mobile in his hands. The mobile doesn't have any connectivity to the terrestrial tower, but then app in the mobile communicates with this gadget, and then through that, in a video compass mode, it points to him where he has to go for fishing. Not only that, if the weather conditions are going to be unfavorable, it alerts him in his mother tongue. And then many times we have read in the papers that our fishermen are caught by neighboring countries because they are crossing the international boundaries. Now this gadget is telling in his mother tongue, you are approaching international boundary, so don't go there. But then many times still they go, that is anyway different reason. But technologically, you are able to alert them. But you can see a person who does not know reading or writing is making use of the most advanced technology of a launch vehicle putting satellites into orbit and then getting information for his livelihood. So you see, in fact, many times you also have seen space technology provides you information which, if used effectively, can be utilized for a whole lot of activities. Today, you have also seen India is using for governance the information coming from remote sensing, not only just images in one wavelength, a whole lot of wavelengths. If you make observation in one wavelength, you get some information. But if you make them in many wavelengths, you can classify them, you can categorize them, and you can study different aspects of that. And then you can also wonder, in India during monsoon period between June to September, it's all cloudy. So what can you see from space? But then, like we can see through glass, microwave wavelengths can penetrate through clouds and make observation. So we have built microwave instruments which can take observation. And then in this manner, you are covering these various observations and using this a whole lot of information with navigation, which gives you position, with the digital elevation model, which gives you base reference, and then lot of images which can be draped on that, which can be used for actually for flying for pilots simulation to doing urban planning, a whole lot of activities. In fact, government has progressively started using, in fact, the Honorable Prime Minister, even when he was the Chief Minister of Gujarat, had made extensive use of both remote sensing, communication, and broadcasting facilities of the Indian satellite system, and then brought in a lot of administrative activities. So when he came to center also, I remember one of the events which was conducted in 2015, where all the center and state secretaries were brought into one place, and ISRO conducted a 2-day event, and then telling them how space technology information can be effectively utilized for various ministries. And on that day, Prime Minister spoke extempore for 45 minutes, telling the secretaries how space technology can be used for governance. And subsequent to that, a lot of things moved on further. And then this Manrega activity, where earlier the event activities were not having proper records, the recording became an activity. Today you have more than crores of assets brought into database. So a whole lot of things are happening. So in a way, what India has done, you can see using space technology, starting from very simple beginning. In fact, I would like to end this narrative with what happened very recently. I was telling you about the India using the advanced technology satellite which America built. So America had built that satellite, and it had almost 12-meter diameter antenna even at that time. And using that site experiment we did. And at that time, we had borrowed entirely that satellite from them for 1 year. And just few days back, you saw India launched NISR, NASA ISRO Synthetic Aperture Radar mission. This was a mission on which we have worked almost more than a decade. What is the uniqueness of this mission? If you look at it, is the first joint mission between India and USA, where ISRO and NASA have worked together, built a payload which provides, based on the latest technology of what is called SweepSAR, which is capable of generating the entire globe information every 12 days at few meters resolution, the information about small changes that can happen on the surface of the earth, changes to the tune of few centimeters or even millimeters. And then it can map biomass, it can map, okay, yeah, you can generate biomass information, and then ice information, a whole lot of information. And this is being done in two wavelengths. One is L band and S band. And then in this also, L band portion of the payload is built by JPL NASA, and in the same, and using the same antenna, S band portion of the payload we have built, and it is integrated at JPL. Then the entire payload is brought to India. It is integrated in our satellite, and we have launched the satellite. And this satellite has almost 12 plus meter diameter antenna, one of the largest antenna for the remote sensing SAR type of activities. And using this capability, you can see in 1975, we borrowed a satellite from them, and they were never ready to work with us in any common mission until we demonstrated Chandrayaan program and our own radar programs. After that, they were ready to work with for a common mission. And this also, if you look at, it is a one plus almost $1.5 billion program. In that, we are spending about zero point 0.2 or so. They are spending the rest. But then the together it's a joint mission. And the uniqueness of this mission is it's almost like you can observe real-time health monitoring of the earth. Like for human systems, if you take, you measure the heart rate, pulse, whole lot of thing in real time, and using models you can predict behavior, etc. See, if you look at what this can provide, a NISR, every 12 days you can cover the entire globe, and you can make measurements about solid earth, you can make ocean, cryosphere thing, plant biomass, etc. And because you are getting it at regular intervals, you can fit it into various models and starts predicting. It can give you precursor for earthquake, etc. A whole lot of things. And unlike many other things, this entire data is also going to be available to the entire humanity. And it's a global coverage at regular intervals, the like of which has not happened so far. So you can see in a matter of 50 years, India actually graduated from entirely depending on the technology from outside to become a joint partner, an equal partner in a huge mission. In fact, it's, if you see the recent both YouTube and other publications that have come, NISR is a huge capability for humanity in terms of remote sensing and in terms of capabilities. There is a huge opportunity also in this, working on this data for a whole lot of applications. And in fact, just progressively, the satellite is moving ahead towards making the antenna. On 15th of August, this antenna will become fully open. And even now, step by step, the booms, etc., are getting opened. Even yesterday, one more step has been done. But then coming back to today's talk, see, if you see this remote sensing, if you look at now, what exactly is this remote sensing and how we have moved ahead, if you look at, in fact, we will all realize that the real development that has happened on planet Earth is because human being is the key element in this, and human being itself is one of the best known remote sensors in this world. In fact, this system as a platform is endowed with 5 sensors which can operate. Out of that, 3 of them are remote, and then other 2 in contact. You have a remote sensor, eye, ear, and smell. You have got remotely sensing, and you have got a set of actuators which you can use for moving the platform to different locations. For example, when you want to see something very close, you will go near that with your legs. And then if you want to take a big picture, you go far away and take the broad picture. For this, the controller is there within you, which we can call as an Asli intelligence. So you are endowed with an Asli intelligence, a set of sensors, and your intelligence progressively tries to learn from all the sensory data, and then it does what we call sensor fusion. I'm sure many of you, when you are analyzing the data, you know what is talked about as sensor fusion. In fact, every one of you have made use of this sensor fusion activity in your real life evolution itself. But probably if I ask you a question, when did you hear of sensor fusion? Maybe just a few years back. But then that mechanism is operating within you. Just to give you an example, suppose I give you an artificial flower and a real flower. Will you be able to make out which is a real flower? Appearance looks exactly same, and then form looks exactly same, but still you will go beyond that. You will start thinking of smell. Even if fragrance is made identical, you will touch and see texture is different. That means your sensor fusion is working. Camouflaging is the same thing. How to showcase to you by whatever sensor you are observing that what you are seeing mimics something else. So it's a constant effort between mimicking what is happening in nature, understanding what is happening in nature through the system that your remote sensor with your intelligence, and progressively building mechanisms outside. Again, if you look at it, our eye as a sensor has a limitation. It has a limitation of seeing only between 400 to 700 nanometers. But you know, in the world, humans realized there were other life forms which are capable of making observation other than visible light. So then what have they done? Today they have built gadgets which can show you what is happening in infrared, ultraviolet, X-rays, microwave. That means, can we say humans have built gadgets to show to you what is happening in nature, what you could not have otherwise seen? So that means, to enhance your eye as a sensor, you have built a whole lot of gadgets. And what was the inspiration for this? Inspiration for that is again nature. In nature, you are seeing how things are happening, and you are trying to build one step at a time. And if you see in this analogy, we can build everything that has happened in human life right from the early times to now. And then if you take this analogy, you will realize that how humans started building machines to reduce his physical labor. Today you have machines which can perform thousands of people's job at a time. And then after taking care of physical labor, you started thinking about your intellectual capability. So now you will also realize progressively things are moving. Now what are we trying to mimic outside? Any idea what we are trying to mimic outside? So far, we were mimicking what is happening in nature to showcase to the humans that you can see what your eye cannot see, what your ear cannot hear. You are translating and bringing it to you. But then now you are getting into a process where you are trying to mimic what is happening within human system and trying to bring it into reality outside. Anybody wants to take a guess? Yeah, AI, for example. Now, if you see, every one of us are endowed with an intelligent system, which right from the childhood is doing this task of taking sensory inputs, making sense of it, interpreting rules, creating its own rules of operation, which earlier period you are talking about expert system. What were expert system? That means by making some rules of operation, you are creating. Now, if you visualize, that is happening within you right from the time you entered this world. Your intelligence is working, taking sensory inputs and trying to interpret based on how people are behaving. In this context, if you really look at, one of the thing perception happen is our ability to speak mother tongue. If you just think about it, why do we speak that language? Because as a system, we are hearing that sound. At that time, it is simply noise. But our intelligence keeps on observing what is happening around, tries to mimic that sound by producing appropriate commands to its voice generation, and then reproduces that, and then through this process built its own rules of interpretation and operation. So if you see, in that sense, we are all remote sensors, but we are building remote sensing systems which can take us. Earlier we were doing building with vehicles, etc. Now we have built rockets. We are going to other platforms, other places. We are looking at how to go beyond other planets, other solar systems, etc. So that means it is a process of trying to mimic what is happening in nature. And in this, we are realizing now you are provided with an intelligence which you are trying to mimic outside, where progressively the systems with more and more memory, higher and higher speeds, and then now digital technology is not sufficient. You are getting into quantum technology. But you also know quantum technology is actually operating in the world. So like that, it is a continuous process. So anyway, I can go on and on. I'll not do that now. I'll just summarize and stop. So what India did when it this whole process of remote sensing started, by trying to build the capability of going beyond planet Earth to use it for observation both within and outside, and then using all this observed information, making sense out of it using in situ observations, and then building models. And progressively, as you keep building better and better models, your ability to predict, your ability to forewarn is improving. And now we are building and putting into orbit more capable systems, and then progressively this will continue. And this process of comprehending our own ability to perform, and then the asli intelligence which we are given with, if we make use of it, we can do far more than what we have done. The inspiration for a remote sensor is here with you, with each one of you. If you try to comprehend how this system is working, you may be able to bring into reality in this world a system which is better than what we have seen up to today. So, and what India and ISRO has shown is that you make use of any technology that is accessible to you, build using that something which is not existing as of today, and move ahead. In this, you can always move ahead of others. You need not be constrained. You need not think that others have better technology, and using that technology they can always override us or move ahead. But we can outperform them if we use, and this is what ISRO has shown all along, by using what is accessible to it, and even borrowing from others, convincing them that if they provide to us, we can do it better. And in this process, it is going on. And today, you have reached, become the third largest economy, or very close to that. And by the time we reach 2047, 100 years of independence, the desire is to reach the topmost, which probably was what this land or this civilization had shown to the world. So all of us have this opportunity to reach there. And every one of you, if you realize the potential you have within you, and by working together as a team, and by making the optimum use of whatever technology that is there, you can achieve wonders. So wish you all a great success in this, and let me thank the organizer for giving me an opportunity to share with you all these thoughts on this remote sensing day, and also the birthday of Dr. Sarabhai. And this is, it will be a great homage to him if we realize that the great thought process which he has initiated, we continue to work on that. Thank you very much.
Sir, we have few questions actually, if you can. So we have received through WhatsApp only.
Yeah.
So the question is from Dr. Bijendra Pataria. He is the director of Punjab Remote Sensing Application Center, and they are hearing your lectures. So the first question is, when India is expected to have human space mission by its own?
Yeah, okay. See, India actually started this human space program. One of the original targets was by the 75th year of independence, we should have put Gaganauts into orbit and bring them back. Of course, the task was convert our rockets into human rated rockets. You can visualize that if you want to put life on any of these things, when life is involved, the human rating of the vehicle becomes important, and then you have to build these capabilities. And while the activities was on target, the COVID brought in a significant disruption in this process, both because of the resource availability and other things. So now this year we are going to have one of the uh, uncrewed mission, preliminary missions, and then later next year we will have two more uncrewed mission, which will be exactly identical to the manned mission, which will be our human mission, which will be there in the following year. And then in a matter of 2 years, India will have its own Gagannauts going in that Gaganyaan program, and things are going on systematically. And we expect in a couple of years our Gagannauts will be in orbit. Not only this, even by the time this is achieved, the government has already decided that we will have our own space station called Bharti Antariksh Station by 2035, and by 2040 we will have our own Indians landing on moon and coming back. So these targets have been set, and ISRO has already started working on this, and then looking at what needs to be done to reach this. And again, for landing on moon and coming back, India is now currently working beyond Chandrayaan 3. We are having Chandrayaan 4, which is a sample return mission. That means you have done the first step of orbiting moon, then landing on moon. Next is bringing a sample from moon back, and then progressively reach landing humans on moon. So this is the way it is expected to progress. In a couple of years, the Indians on orbiting Earth. Then in the meantime, you also saw Shubhanshu Shukla making use of the opportunity available through International Space Station, learning some more aspects of this mission, which will come in handy for our own efforts, which is going to happen in a couple of years, and then station and landing on moon by 2040.
Thank you, sir. There is another question, because nowadays states started thinking of their own satellites. So question is, can Indian states may have own specific small satellites to cater needs of its own particular usage?
Yeah, if you look at what India has done and has started doing, why the whole lot of changes were brought in. See, initially when you have building the capacity and capability, so India demonstrated when the cryo engine was not available, you built your own. So you built and demonstrated that you can put satellites up to certain weight at different altitudes. And then if you want, everything had to happen within the government sector, then we are going to miss out on the space economy. Space economy is expected to reach $1 trillion in a couple of years. And India, which has an end-to-end capability of building launchers, satellite applications, etc., should it be limited to only government-owned activity? Then the number of participants will be less, and the government will have to find the funding. So what India government did is making it accessible, and then more and more participants in the country. So it brought in change in the rules of operation. It brought in NCIL, it brought in InSpace. InSpace is now promoting space activity in the country, It is enabling more and more private entities. Already some companies are building rockets, their own 3D printed engines. In fact, very soon you will also see the promotion where a group of consortium will have their own constellation of satellites operating, providing this data. In a matter of 3 to 4 years, this will become a reality. And then more and more private companies will have the opportunity to own and operate satellites. So in this context, there is no real limitation. Any state government can also make through these kind of opportunities, have a satellite providing them specific information, what they want. The whole idea is to enable the country to participate and make use of this technological capability of using space for various applications.
Thank you, sir. Now, sir, we will take last question. There are questions, but last question. How Nisar mission will be helpful for state disaster response system? Is there any planning for joint collaboration with the state disaster management authority regarding the usage of this useful satellite?
Yeah, in fact, it is one of the very key things. In fact, what has been happening over last many years, how to make use of the Nisar data, events are being conducted. In fact, just prior to launch also in Tamil Nadu, a 2-day workshop was conducted where a number of people from across the country had participated, and even SDRF of Tamil Nadu also had participated. So there is a whole lot of information which is going to get generated on a repetitive basis, which can get into various kinds of, for example, from flood monitoring to even building plans for future disaster hazard mapping, improved mapping capabilities will be possible. The possibility is enormous and lot more work has to happen. Though many efforts have been done in last couple of years, it's inadequate. And then even entities like ISRS can take up this on a much more concentrated manner. All of your chapter, in fact, when you mentioned 28 chapters, I was wondering why it is only 28, why we do not have in all states and all union territories, and how these chapters can engage more and more student groups and then bringing education. And in that, using this Nisar and then similar thing, both early warning and prediction, etc., how to make it effective. In fact, Nisar is going to provide, like I said, hard means in fact the real-time monitoring of the earth, various parameters, subsurface to surface to atmosphere, a whole lot of things are there. So in fact, it is touted as an instrument or an ability to observe the real health of the satellite. And using that, like today, people are predicting 24/7 your health parameters are monitored, and using that what will happen 72 hours later or months later. So same way, this data can go into such models, but then more and more people have to work on that and bring out their own models. So opportunity is tremendous. We need to make it happen.
Thank you.
Sir, should we also take a couple of questions from
Yeah,
here?
Yeah, from
If
audience,
there is
current
any, yeah.
here only. Can you show the audience and the TV?
Yeah. Or any question from our colleagues here?
Yeah, any question? One question we can take up. Yeah,
Yes, yes.
Mike, you can use.
Sir, I asked this question to many because I'm not getting these answers actually. So nowadays, people are now putting some missions. Like you are also telling that some mass will be bringing from moon. Then some mission like Rosetta and all, they are also planning to bring some mass to our resources, natural resources to our Earth. As per gravitational law, if we bring mass, if we increase the mass of this Earth, then as per gravitational law, a rotation of the Earth will be changes. Then yeah, in future, maybe another 50 years, 100 years, definitely people will bring mass to our Earth. How scientists is now thinking on that? What is the measures? But this is not related to maybe. But
No, I agree
yes,
with you. No, that's where what I was trying to tell is again. See, this is where the reality really strikes. Humans, when they started life on this planet Earth, had the difficulty of survival itself, isn't it? They had to fight with other animals for survival. So first they found how to survive. But there is one thing which is operating with the human system, the asli intelligence, has got a driver which keeps telling, mimic what is happening in nature and evolve yourself. I'm just giving you a thought process. That means now what happens? He started looking at sky. He started making sense of it. Now he is looking at what if I bring some sample from there, try to understand how the universe formed. Like that, it goes on. No? That means there are people who want to do something simply because, like somebody said, I want to climb Everest because it is there. Somebody wanted to go to moon because it is there. So in the same way, when you do certain thing, you are changing an existing scenario. Now what you are asking is, what is the impact of that? If you say that also, when you do redistribution of mass on earth, when you are building big towns, cities, etc., etc., you're doing a lot of redistribution. You are actually decimating big mountains, converting them into, in fact, if you travel from airport to city in Bangalore, you will see huge mountains being all converted into stone quarried and do. That means all these are going to happen. But then what is going to be its impact will also be, there are people who are doing such studies. As your ability to bring models, create models and understand increases, you are making such models and trying to understand. So it's a constant process. Same problem with respect to debris. When humans thought of putting an object in space, at that time, will anybody worry about what I'm going to leave there? At that time, their only desire is how to make it open and orbit. Today, how many such things you have left? People are building 40,000 satellite constellation. So debris is becoming a waste management problem there. So same way, what you are saying is also that a few grams in 10 pot 39 or 40 kilograms of earth, what impact it has got? Definitely, it has got an impact. Maybe femto second it might modify, but then that will become significant at some point of time. So there are people working on such things. Their ability to do that will improve when you provide them better and better tools. That is where quantum computing, when it becomes a reality, will give you a computational capability which is far superior to what you have today. But then you will start addressing problem which is much more difficult than today's.
Yeah, I think, yes, sir. Yeah. So we'll close this session, and I'm sure everybody will agree that this has been truly an illuminating talk, highlighting the journey of Indian space program and showing how innovation has been the central to this component, and how innovation has helped ISRO to overcome the challenges related to the shortage of resources at different times, and which also coincides with the theme of this year's National University Day. So I'll again request all my colleagues to give a big round of applause for this excellent talk. So yeah, so now, yeah. So I'll request Dr. Nisar, as mark of our appreciation, to present a memento to our sir. Yeah, no, we'll come. Yeah.
Since you came here, so, thank you, sir. Now I request Dr. Praveen Thakur, Secretary of Indian Society of Remote Sensing, to propose topics.
Yes, thank you, sir. It has been a real proud privilege and honor for us, all ISRS members, to listen to our beloved Dr. Kiran Kumar, sir, former Secretary, Department of Space and Chairman ISRO. And he has also been the guiding force of Indian Society of Remote Sensing. He has guided us as a president of ISRS for many years. And I also thank President ISRS, Dr. SP Agarwal, under whose leadership we are organizing this today's National Remote Sensing Day 2025 celebrations. So it has been real knowledgeable, and the way sir has taken us from the days of Sputnik to the initial days of ISRO, elaborating the site experiment Aryabhatta satellite, how we hired that from the US, and then the Insat 1 series, and the unique innovations in the Earth observations, where in the single platform the three different resolution at different repeat were realized by ISRO under IRS 1C mission, and also how ISRO has progressed from 1 kilometer to 30 centimeter resolution over the years. And sir has also highlighted various innovations which has made ISRO the world leader, especially in the reset Chandrayaan series Mars orbiter mission, and various scientific discoveries these missions have made, right from the discovery of water molecule to the global satellite images of the Mars. And sir has also highlighted the role of ISRO in the national governance, that is the geo governance, which was boosted by 2015 national meet, where various government monitoring, for example, Manrega was monitored. And the recent achievement of ISRO, how we hired the satellite from NASA and to joining hands in making a joint Nisar mission with the SweepSAR technology, which helps to give the planet Earth monitoring. And sir has also highlighted the human as a remote sensing platform and the various intelligence, what we call, sir, the asli intelligence, where we must join together to solve real world problems. And sir has given us the task that as a team ISRO has shown over the years, we should target to become the world's best and biggest economy, and by 2047 we should achieve this target. We really thank from on the behalf of all the ISRS members who have joined today, and I personally thank our EC members and ISRS members. More than 100 members have joined, and I would like to also convey you, sir. Today I am at Kendriya Vidyalaya Shimla Jitog as part of the National Space Day celebration. So I have been joined by more than 100 students from class 9th to class 12th who has listened to your valuable lecture. So once again, on the behalf of ISRS members, EC members, and all the other participants who have joined in online and offline mode, we thank from bottom of our heart for taking this journey of ISRO from the early days and in the what lies in the future. So thank you very much, sir.
Thank you, sir. So it is indeed an honor that sir has visited NESEC and he is in NESEC. So I request all the scientists to give him a standing ovation, sir. Thank you very much, sir. Thank you, sir. Thank you, sir. Thank you. Now we can close the session.
Variance height also for all stays up just outside this room.